Welcome to Curve Sketching Possible Graphs number 2. All right, so now on this one, I already have a lot of the writing up, but I am going to do the graph with you. It might go a little faster, especially because you've seen one of them, right? So you kind of have an idea how to interpret the information. All right, so we have first piece of information, f of 0 equals 0. I already have that point right there on our graph, so that's telling us that, just like in the last one, that 0, 0 is a point, right? So we've got an x-intercept and a y-intercept all in one. We've got some information about the first derivative. It has the big old green dot next to it. I'm making these a big green dot. All right, so first derivative at negative f, so f prime of negative 2 equals f prime of 2 equals 0. F prime of 0 does not exist. That's what this means here, right? So the backwards E means exist. A line through it means does not exist, all right? So right here, that's telling you f prime of 0 is undefined. It is a critical point because the first derivative is undefined there. All right, so now think about it. We remember why the first derivative would be undefined, right? There's either a corner, there's a cusp, or there's a vertical tangent. Right, and here we go. Ooh, here we go. Do. Any day now. All right, I'm going to go use the mouse, because apparently that will go faster. All right, so I added that information from the point. Hey, where is my, oh no, spinning ball of death. Oh, there we go. All right, so I already added in f point 0, 0 is on f of x, right? Because we're told f of 0 equals 0, right? So we have that point there. All right, first derivative information. Come on. All right, so critical points at f prime of x. At f prime of x for x equals, you can stop now. X equals negative, I said you could stop. Well, it's just going to keep on going, isn't it? Good. Come on. Stop. Well, ignore it. It's going to very slowly go. I won't have to move it again. All right, so at x equals negative 2 and x equals 2, possible extrema. Right? F prime of negative 2, because f prime of 2 and f, now let's go the other way, f prime of negative 2 and f prime of 2 equals 0. There's also a critical point at x equals 0 because f prime of 0 does not exist. It's undefined. All right. So we have that piece of information from the first derivative. And we're also given another piece of information. All right. So still with the first derivative. Right? But now I wrote it in red. You can see the little red dot. So it tells us the first derivative is greater than 0 if x is less than negative 2. So that means it's increasing when x is less than negative 2. Or if x is between 0 and 2. The first derivative is less than 0, so it means it's decreasing between negative 2 and 0 or greater than 2. All right, so I put that in the red pieces of information. So f of x is increasing on negative infinity to negative 2 and 0 to 2 because f prime of x is greater than 0 if x is less than negative 2 or between 0 and 2. F of x is decreasing on negative 2 to 0 and, come on, and 2 to infinity, because f prime of x is less than 0 if x is between, here we go, if x is between negative 2 and 0 or greater than 2. We're just going to let that keep on going. So I have a sign chart there. All right, whoops. Well, I didn't do any of those things. I must have hit them on the way. That was not, oops. Oh, simple. I'm going to do this. Undo, drop, and drag. Undo, drop, and drag. You can tell this is live because I have to do this. Undo, drop, and drag. Any more undo? No, that's it. Okay. All right, so there's my sign chart in red. All right, so we have critical points there at negative 2. and 2, squeeze that in somewhere. Yeah, back into my, oh, that and 2 goes there. Let's just make sure that my sign chart looks right. So we got a critical point at -2. What happened to my critical point? I got my critical point at 0. What happened to the critical point at 2? That just seems to have disappeared altogether. I am going to try to erase this and make this a little cleaner. Because I can't even find one of my critical points on that. Just going to get rid of that. Okay. So we had critical points at -2, 0, and 2, right? Because, whoops, that's not a 0. At 0, it's an undefined. Right? Less than -2, it was positive. This one was a 0. Between -2 and 0, it was negative. I've learned to write smaller, I guess. Between 0 and 2, positive. And then greater than 2, negative. All right, so let's see what this part here says. And see if I have to clean it up at all. X equals -2 is a relative maximum because f prime of x changes sign from positive to negative. X equals 0 is a relative minimum. So just because the first derivative doesn't exist does not mean that that can't be a relative max or min. In this case, it's a relative min because it changes, first derivative changes sign from negative to positive. And then, so we have a critical point at x equals 0 because the, oh, I'm sorry, we're going on to the second derivative there. Where did I not have, we're missing one of ours. So let's, oh, that's why that thing was in purple there. So x equals -2, let's clean that up because we're missing x equals 2. All right, so x equals -2 and x equals 2. Let's change is to r. Yeah, we don't need an a in there. Oh boy, I need to make that smaller. It's erasing all kinds of things. R, relative max, right? On both of them, right? We change, so here, I'll write in blue. In here we change from positive to negative. Here we change to from positive to negative. Both of those are relative maxes, right? And then the 0 is a relative min. I'm going to get rid of that screen altogether. The last thing to consider is the second derivative, all right? And so second derivative, we have a critical point at 0 because the second derivative does not exist, all right? That is the only critical point right there. It says it, right? F prime of x, or f double prime of 0 does not exist, all right? So that means it's a critical point. Let's see what other information we're given. We're given that f double prime of x is less than 0 for all x except for 0. So that means that f of x, and I'm writing right here, so right here is that information. F of x is concave down everywhere except x equals 0. Right? This doesn't exist for, that's, so what does that mean? That's going to be an inflection point. We have x except x equals 0 because that doesn't exist for the second derivative. That's basically it. So, and we know that because f double prime of x is less than 0 for all x that is not an inflection point, right? For all x, oh, here's where the thing goes. I'm going to just do this. I'm reading my words and I'm like, what? You're probably reading them and going, where does it go? So it's concave down everywhere except x equals 0. Now let's look at the sign. Notice it's concave down. So 0 is not, this is one little boo-boo here. It should not say that the second derivative is 0. It should say, sometimes I get carried away on my critical points and just keep putting 0. It should say undefined, right? Because the second derivative was undefined there, but that does make it a critical point. On either side, right, everywhere, it is negative. It is less than 0. So x equals 0 is not an inflection point because f double prime of x does not change sign. What happened to the e in that word? All right, to be an inflection point, the second derivative has to change sign. All right, so the derivative, I just put a little note here. This refers to this right here not existing. Right? So the second derivative does not exist at x equals 0, both here and here. Right? So on the first one, it could be a vertical tangent line, a corner, or a cusp. Let's see which one it is. Doesn't exist for either of the derivatives. How about that? And then we'll read my little ending part there. So one thing we know for sure, there are no discontinuities in this graph, right? This is a connected graph. If f of x has a derivative at an x value, f of x is continuous at that x value, differentiability implies continuity, right? The only place we have an issue is at that 0 there, and that's because we have a cusp. So this is actually a really easy graph to draw. Think of McDonald's. And this is why I say that. Concave down. Just missed it. Concave down. We've got a cusp right here. Still a concave down. Oh, isn't that nice? Now I got to make sure I put the only thing I got to make sure of is that my relative max and min are in the right spot. Made my little m's too big. Right? Because my relative max and mins have to be at 2. But that's going to be our basic shape. I will tell you again when it is good. I'm going to try and do this. I got to hit this. All right, that's where it's going to be. I got to hit this point, -2 and 2, right, are the relative maxes. So I want to hit that as the relative max. So I'm aiming. Doesn't matter where on the y. All that mattered is on the x. All right. Turn. 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 I'll take it. That looks fine. All right, and it's going to keep on going there. Could draw that a little bit smoother, but go ahead. You may draw this smoother. I said you may draw this graph while I try to fix the last little part of my M. So see what I mean? It looks like to me a McDonald's sign. All right, so let's draw those in there. So let's put our information in here. So this was a relative max. Right here, we got another relative max. So right there, relative max, relative min. All right, so even though none of the derivatives exist at 0 because of that cusp, it still is a relative min, and then we are concave down everywhere. And that's this graph. We're done. All right. I thought this was kind of an easy graph. It didn't take me as many times to get it nice, perfect, and smooth. All right. Thanks for watching. Come back for one more possible graph, and then we'll kind of finish up with curve sketching and possible graphs in a fourth podcast. But so 2 more podcasts to go. Bye for now.